parallelogram. Now, the figure on your right shows a parallelogram. Opposite pair of sides are parallel and equal. This side is parallel to this and equal, like same as the case of rectangle, with the difference being the vertex angles are not 90. If I make the vertex angles as 90 degree, it will be the same case as the case of rectangle. So I can say rectangle is a special case of parallelogram where the vertex angles are 90 degree. So opposite sides are parallel and equal. Opposite angles are equal in case of parallelogram. Vertex angles are not 90, but opposite angles are equal. So I can say angle B is equal to angle D, angle A is equal to angle C is what I have in case of parallelogram. The two diagonals that you have are not equal because the vertex angles are not 90 degree. Diagonals are not equal in length, but they bisect each other. So this part will be equal to this part, which is AO will be equal to OC, but BO will not be equal to OC. Diagonals bisect each other, but diagonals are not equal, and diagonals do not bisect at 90 degree. This angle would not be 90 degree. This is only 90 degree in case of square. Sum of two adjacent angles, if I talk about angle A and angle B, sum of the two adjacent angles that you will have would be supplementary or would add up to give you 180 degrees. Other property of parallelogram being the sum of squares of diagonals is equal to the sum of squares of all the four sides. So what I have is AC square plus BD square, which is the square of the diagonals that you have. You have sum of squares of the diagonal is equal to 2 times, because you have two sides which are same, L square plus B square. This is a property that can be applied inside a parallelogram. Each diagonal of a parallelogram divides it into two congruent triangles. If I look at BD as the diagonal, triangle ABD and triangle BDC would be congruent. Very simple reason, because the opposite angles are equal, right? Opposite sides are equal, opposite sides are parallel, so it will be dividing into two triangles which are congruent. Similarly, if I talk about AC as the diagonal, triangle ABC will be congruent to triangle ADC. The two triangles that you will get would become congruent. In order to find out the perimeter, it will be sum of all the sides, L plus B plus B. Combining the similar terms, I'll get 2 times L plus B. Finding out the area of a parallelogram, you can find it out by dividing it into two triangles, finding out the area of one, multiplying it with 2, because the two triangles that you get would be congruent. So I can find out the area of one triangle with any of the formulas, half, base into height. When I multiply it with 2, that half thing will get cancelled out with 2 to give me the formula, which is base into height. So I can devise the formula as the base of this, which is AD, into height, which is BL. This can be one formula that I have, which is base into height. The other formula that I can derive is by taking the diagonal as the base. So if I take AC as the base, I can find out the area of 1 and multiply it with 2. So if AC as the base, BH will be the height, so it will be AC into BH. That half thing that you will have will cancel out with the 2 factor to give you only this. Or you can follow the formula half AB sine A, half AB sine C, sine of the angle between them. This half will get cancelled out with 2. So you're left with the formula L into B into sine of the angle which is made between L and B. L and B being the two sides of the parallelogram that we have. A parallelogram that is inscribed in a circle is always a rectangle. So if a circle is given to you and you have to draw a parallelogram inside the circle, that case will only be the case where you have a rectangle. A parallelogram inscribed outside this will be a case which will be the case of rhombus. We'll talk about rhombus after 2-3 minutes.